Algebra II 2.7c, Equations and Inequalities with Absolute Value. Now, if you don't know that much about absolute value, you really should watch 2.7a and 2.7b first before you watch this video, because we're at the end of the lesson with 2.7c, and links to those two videos are in the description of this one, so you can just click on them. So we can solve and graph equations and inequalities that involve absolute value. The absolute value of x equals 4, well, the solution set just contains the numbers x whose distance from 0 is 4. So we've got a negative 4 and a positive 4. To solve and graph the solution set, the absolute value of 4 is less than 4. Then the solutions are the numbers whose distance from 0 is less than 4 and doesn't include 4. We can write our answer in set builder notation as the set of all x such that x is greater than negative 4 and less than 4. And when we graph it on a number line, we use the open circles to show that the 4 is not included, right? Or the negative 4. We can solve and graph the solution set that the absolute value of x is greater than or equal to 3. And the solutions are the numbers whose distance from 0 is greater than or equal to 3. So that means the numbers x such that x is less than or equal to 3 or greater than or equal to 3. And we can graph it with two different arrows on the number line. It's using a black dot because the 3 has an or equals to, so it's included, and that's exactly how we write it in set builder notation, just like that. So I've got a theorem for you and a few principles. These are the principles for solving absolute value sentences and for any positive number b in any expression, the absolute value of n. So remember, the n is going to be what's the absolute value, okay? And I'm going to show you examples of each one of these. So this first one is saying that we're going to split it up with an or in between it. We're going to make the n equal a negative b or a positive b. The second one says if it's a less than, then we're going to put our absolute value amounts in the middle and make it greater than the negative or less than the positive. And our final ones, if it's greater than b, we're going to make it an or. And if you notice, the sign is saying that this is greater than b, right? When we write it like this, it's going to be less than a negative b or greater than b. See that? How the sign switched right here? It's going the other direction. So here's our first one. If we need to solve and graph it, and here's the principle written right here that we're going to use, the first principle. We've got the absolute value of 5x minus 4 equals 11. We're going to set it to equal 11 and to equal negative 11. See? It's going to be a negative b or a b. And we just solve them the way we normally solve an equation. We use inverse properties, and we can get rid of this 4 by adding 4 to each side, and we get 5x equals 15. We can use that multiplication property of inequality to divide both sides of this by the 5 coefficient. So we get 1x equals 3. And on this one, we get rid of the 4 by adding 4, and we get 5x equals negative 7. Again, using this property, we can divide both sides by this coefficient 5, and we get 1x is equal to negative 7/5. And that's our solution, negative 7/5 or 3. It's just one or the other. And we can graph it, negative 7/5 and 3. Okay? So we split it up and we set one to equal the negative and one to equal the positive. See? When it was like this. All right. Here's using the second principle. Now, and we used this one because it had an equal sign. Okay? That's when it equals it. And then we're going to have a less than and then a greater than example. Okay? So here's the less than example. We've got the absolute value of 3x minus 2 is less than 4. So we're going to use that second principle that is going to set our values in the middle, and it's going to be greater than a negative and less than a positive. And that's how we write it. We write our 3x minus 2 in the middle here, and we set it so it's greater than a negative 4, but less than the positive. See? Now, what we can do is, with the addition property of inequality, to get rid of this minus 2 right here, we can add 2 to each part of this inequality, to each term. So we add it to the negative 4, we add it to the negative 2, and we add it to the 4. And we get negative 2, we get a 3x because that's eliminated, and we get a 6. And now, because of the multiplication property of inequality, we can divide each term by this 3 coefficient of x. See that? So that's going to create 1x. That's going to give us negative 2/3, and that's going to give us a 2. And we can graph this. X is greater than a negative 2/3, and it's less than a 2. And it doesn't include them because it doesn't have or equal to, so we're using the open circles. See that? All right, here's our final one, and this is when it's greater than, okay? So I want you to notice, first of all, here's the third principle, all right? So we're going to split it up that the n is going to be less than the negative or greater than the positive. So you notice the sign got switched? So we had the absolute value of 4x plus 2 is greater than or equal to 6. We're going to switch this sign around when we put it with the negative, see? And when we do it with the positive, it's going to go the other direction. And we can use our additive inverses to get rid of this 2 by subtracting 2 from each side, or adding a negative 2 if you want to put it that way. And we get 4x is less than or equal to a negative 8. We can divide each side of the inequality by this 4 coefficient, and we get 1x is less than or equal to a negative 2. We do the same thing on this side, subtracting a 2 or adding a negative 2, however you want to look at it. It's getting rid of this 2 here. And we get 4x is greater than or equal to a 4. We divide each side by the 4 coefficient, and we get that x is greater than or equal to a 1. So that was using the third one. Just notice that the sign got turned around, all right? Now, we can read this negative of b right here. We can read it as the opposite of b, the negative of b, or the additive inverse of b. But we don't read it as minus b or negative b. It would be negative of b. See that? So you're going to come across this as you get farther into math, all right? Okay, so our next video is going to be 2.8a. We're going to talk about conditional statements, and the link to the Algebra II playlist is going to be in here so that you can go back and see 2.7a and 2.7b and any other videos you may have missed. And I'm going to have a link to my Algebra I chapter playlist about inequalities and absolute value. So if you're really lost, maybe going back to Algebra 1 and watching a few videos to remind yourself of what happened last year is going to be a bigger help for you, okay? All right, let's talk about conditional statements, and I hope you're doing well, and I hope I'll see you there. Bye.